Hi folks, so we're going to do 8.2 today, which is vector methods with projectiles. So essentially how to do projectile questions using vectors. Now there's only one question today, so you need to choose whether you want to pause it or have a go alongside me, okay? So they've given me a nice diagram which will help me visualize it. So I'm just going to pick out information from this question because it's quite wordy. So a ball is struck by a racket from a point A which has position vector 20j meters relative to a fixed origin O. Okay, so I could label that as position vector going from O to A, and they've told me that that's 0, 20, so that might come in handy in a bit. They told me the initial velocity is 5, 8. They said the ball travels freely under gravity, so I can say the acceleration is 0 and then minus g, so minus 9.8. And then they want me to find the speed of the ball 1.5 seconds after it's being struck. So t is 1.5. I want to find the speed, but I need to find the velocity first. Okay. So I've got UAT, I want to find V, so I'm going to use V equals U plus AT. So I'm going to sub in all the bits and pieces I have. So I've got 5, 8 plus 0 minus 9.8 times by 1.5. So I've got 5, 8 plus 0 minus 14.7, and I put that all together, I've got 5 minus 6.7 meters per second. So if I want to find the speed, I need the magnitude of the velocity, so that will be 5 squared plus negative 6.7 squared. So I pop that in my calculator and I end up with 8.4 meters per second. And I've done it to two significant figures because I'm using G to two significant figures. Okay, so that's part A. Part B, find an expression for the position vector R of the ball relative to O at time t seconds. Okay, so we basically, I can use the diagram as a bit of a reference. We want to find out sort of the position vector of R at some point. So if we just labeled this as R, we don't know where it is. It's sort of at a generic time. So we want to find out what this is. So in order to do that, we can find this using our SUVATs, and then we can add on this part here because we already know that bit. Okay, so the first thing we want to do for part B is we want to find R, and we could do that using, so let's call it RA. So that's going to be looking for this position vector here. Okay, so we can do that by using R equals UT plus half AT squared. Okay, and just use all the information that we've got already. All right, so I know that U is 5, 8, and I know that the acceleration is 0 minus 9.8 t squared. So if I just simplify that a tiny bit, so I've got 5, 8 plus 0 minus 4.9, and then that's t squared. So I just put that all together. So I've got 5t on the top and then 8t minus 4.9 t squared on the bottom. Okay, so that's the displacement relative to A. So then if I want the position vector relative to O, I'm going to put together, so I'm going to put that vector together with the one I had at the beginning, so my O to A one. Okay, so I've got 5t, 8t minus 4.9t squared plus 20. Okay, So that's part B, and don't forget units. So part C says, hence determine the distance OB. Now, if you look at the diagram, you can see that OB is this bottom line here. Okay, so when we go from O to B, the displacement for the J component would be 0. So what we can do is we can let the J component of our position vector equal 0, find the time at which that happens, and then we can substitute that time into our I component and find the total distance. Okay, so last part says, hence determine the distance OB. Okay, so what we can do is when it goes from O to B, we know that the J component will be 0. So we could let the J component equal 0, find out the value of t where that happens, and then substitute that into our I component and therefore find the distance. Okay, so first thing we need to do, so using our equation from the previous slide, we can say that we've got 8t minus 4.9t squared plus 20, and we can say that that equals 0. Okay, so we've got a nice quadratic. So if I use the quadratic equation, I've got t equals minus 8 plus or minus the square root of 8 squared minus 4 times minus 4.9 times by 20, and then that all over 2 times minus 4.9. Okay, so pop that into my calculator and I get t equals negative 1.362, etc. Or I end up with t equals 2.995, etc. So obviously can't be the negative one because we can't have negative time, so we're going to sort of ignore that. So if we substitute the time into our I component, the distance is going to be 5t, so 5 times 2.995, which if I put in that into my calculator, gives me 15 meters, again to 2 significant figures because I've used gravity to 2 significant figures. Okay, and that's it. All right, so 8.3 will be coming soon.